This is the IB Core Mathematics Paper 1 from 2021, and we are going to be going through question 5 in this video. Okay, so it's a sequences and series question, and part A requires us to find the general term of the series, or of the sequence. So what I'm going to do is I'm going to rewrite the series as a sequence. So I have 4, 9, 18, 31, 48, and then a whole lot of terms following that. Now I need to find out whether this is going to be an arithmetic series, in other words, with a constant difference, whether it's going to be a geometric series with a constant ratio, or a quadratic series with a constant second difference. Okay, so if this were to be an arithmetic sequence, then there would have to be a constant difference between all of our terms. So let's find the difference and see if it is constant. So the difference between 9 and 4 is 5. The difference between 18 and 9 is 9. 31 and 18 is going to be 13. And 48 and 31 is going to be 17. So as you can see, none of those are equal, and so we don't have a constant first difference, and so this is not an arithmetic sequence. But now let's consider, could this be a geometric sequence? Well, in order for it to be a geometric sequence, we have to have a constant ratio. In other words, when we multiply 4 by a number, we get 9. And if we multiply 9 by that same number, we should get 18. So how do we find out if we have a common ratio? Well, what must I multiply 9 by to get 18? Well, of course, I must multiply by 2. Now, if I multiply 4 by 2, do I get 9? Well, 4 times 2 is 8, and 8 does not equal 9. So it can't be a geometric sequence since there's no common ratio. So we're hoping now that it's going to be a quadratic sequence. So let's go ahead and check. So the difference between our first differences, so 9 and 5 gives us a difference of 4, 13 and 9 gives us a difference of 4, and 17 and 13 gives us a difference of 4. Okay, so we can clearly see that we have a constant second difference, and this is thus a quadratic sequence. Okay, so a quadratic sequence takes on the form Tn is equal to an squared plus bn plus c. Now, we need to find our coefficients, a, b, and c. So we know that our constant second difference is going to be equal to 2 times by the coefficient a. We know that our first term of our first difference sequence, this is our first difference sequence, all of these terms, and our first term of that is 5, and that must be equal to 3a plus b. And then our first term of our sequence must be equal to a plus b plus c. All right, so now we can go ahead and solve for a, b, and c. So if 2a is equal to 4, that implies that a must then be equal to 2. Okay, well, if a is equal to 2, and we have that 3a plus b must be equal to 5, and then we substitute in 2 for a, we get 6 plus b must be equal to 5, and if we rearrange, we get b must be equal to -1. Okay, so we have a, and we have b. Now we need to find c. Well, a plus b plus c must be equal to 4, so 2 minus 1 plus c must be equal to 4, which means that 1 plus c must be equal to 4, and c must be equal to 3. Okay, so we have a, b, and c, and now we can substitute them in and express our general term. Tn is equal to 2n squared minus, because our coefficient of n is -1, minus n, and our c value is going to be 3, plus 3. So there we have solved for the general term. Okay, so the next question requires us to find the number of terms in the series. Well, we know that 949 is the last term in the series, and we know the general term. So if we can find out what the index is of this last term, then we know how many terms there are. So I'm going to say, let Tn equal to 949. So therefore, substituting in 949 for Tn in this formula over here, we get 949 is equal to 2n squared minus n plus 3. Okay, so rearranging this into standard form where we have 0 on the left-hand side, we have 0 is equal to 2n squared minus n and then plus 3 minus 949 is minus 946. Okay, now this is quite difficult to factorize, so I suggest you type it into your calculator, which will give you the answers directly. But if you were to factorize it, you'd get n minus 22 and 2n plus 43. Okay, so this implies then that our solutions is n minus 22 equal to 0, or 2n plus 43 equal to 0, which then implies that n must be equal to 22, or n must be equal to negative 43 over 2. And since n must be a positive whole number, it clearly doesn't make sense for n to be equal to negative 43 over 2, and we can conclude that n must be equal to 22. So we can therefore say that there are 22 terms. Okay, so moving on to the last question of question 5, it asks us to represent the series that we've been working with using sigma notation. Okay, so sigma notation in general to represent a series will look something like this. We'll have our sigma, and we'll have our index, n is equal to 1, equal to up to some number, let's call that k, which should be the number of terms in your series, and then we have the general term. So we need to express that. So that is going to be equal to 4 plus 9 plus 18 plus 31 plus 48 plus, and all these terms in the middle, all the way up to 949. Now, this here, specifically, we're going to have the sum from n is equal to 1, our first term, all the way up to our 22nd term, and now we must insert our general term, Tn, which we have discovered to be 2n squared minus n plus 3. And there you go, we've expressed it in sigma notation. Now, if this doesn't really make much sense to you, I encourage you to think of this in this way. Okay, so we take our general term and we substitute in this first index, n is equal to 1. And what that gives us is 2 times by 1 squared minus 1, which is 2 minus 1, which is 1, and then plus 3, which is 4. And then 2, 4, we're going to be adding on the next term, which has the index n is equal to 2. So we substitute in 2. So then we have 2 times by 2 squared, which is 2 times by 4, which is 8, and then 8 minus 2 is going to be 6, and then 6 plus 3 is going to be 9. And then we take for n is equal to 3, and you'll end up getting 18. And you do that all the way until you get to the index n is equal to 22, which will output the number 949. So as you can see, it's an equivalent way of writing your series. So I hope you found this video useful and interesting, and if you did, please don't forget to leave it a like and subscribe to the channel. I'm going to be following this video up with subsequent videos on question 6 and the following questions. Thank you.